Okay, let's talk about how to figure out how many trainable weights there are in a dense neural network. So let me draw a network for you. Okay, we've got the inputs on the left, we've got the outputs on the right. The number of neurons in each layer, we've got, I'm going to use just the letters of the alphabet. A, inputs, B, hidden neurons on the first hidden layer, C on the next layer, then D, and then E, outputs. Now we want to make sure not to forget the bias. The bias is like index 0 on each of these layers, except for the output, okay? And then what we're effectively doing is we're counting the number of lines. So let me draw the lines from A to B. The dense layer by itself, the way to compute the number of red lines there is simply by taking the number of inputs A, adding 1 for the bias, and multiplying that times B. Okay, we can do that for the remaining layers as well. So on the second layer, we have B plus 1 times C. The next layer, we have C plus 1 times D. In the last layer, we have D plus 1 times E. So let me put some numbers to that. Suppose that we had 10 inputs, and then 100 hidden neurons, then 200 hidden neurons, then 100 hidden neurons, then 5 outputs. We might describe the network using this notation at the top for a dense, fully connected network. Plugging in the values here, we would see that we have, working out the math, note how we got each of the 4 layers here individually and then sum them all together. That's all there is to it for a dense neural network.